Racket programming language. Racket is a general-purpose, multi-paradigm programming language based on the scheme dialect of Lisp. It is designed as a platform for programming language design and implementation. In addition to the core Racket language, Racket is also used to refer to the family of programming languages and set of tools supporting development on and with Racket. Racket is also used for scripting, computer science education, and research. The Racket platform provides an implementation of the Racket language, including a runtime system, libraries, and JIT compiler, along with the Dr. Racket Integrated Development Environment IDE written in Racket. Racket is used by the Program by Design Outreach program, which aims to turn computer science into an indispensable part of the liberal arts curriculum. The core Racket language is known for its extensive macro system, which enables creating embedded and domain-specific language constructs such as classes or modules, and separate dialects of Racket with different semantics. The platform distribution is free and open-source software distributed under the Apache 2.0 and MIT licenses. Extensions and packages written by the community may be uploaded to Racket's package catalog. History. Development. Matthias Felleisen founded PLT in the mid-1990s, first as a research group, soon after as a project dedicated to producing pedagogic materials for novice programmers, lectures, exercises/projects, software. In January 1995, the group decided to develop a pedagogic programming environment based on Scheme. Matthew Flatt cobbled together Mr. Ed, the original virtual machine for Racket. In the years that followed, a team including Flatt, Robbie Findler, Shriram Krishnamurthy, Cormac Flanagan, and many others produced Dr. Scheme, a programming environment for novice Scheme programmers and a research environment for soft typing. The main development language that Dr. Scheme supported was named PLT Scheme. In parallel, the team began conducting workshops for high school teachers, training them in program design and functional programming. Field tests with these teachers and their students provided essential clues for directing the development. Over the following years, PLT added teaching languages, an algebraic stepper, a transparent read-eval print loop, a constructor-based printer, and many other innovations to Dr. Scheme, producing an application-quality pedagogic program development environment. By 2001, the core team Felleisen, Findler, Flatt, Krishnamurthy had also written and published their first textbook, How to Design Programs, based on their teaching philosophy. The Racket Manifesto details the principles driving the development of Racket. Version history. The first generation of PLT Scheme revisions introduced features for programming in the large with both modules and classes. Version 42 introduced units, a first-class module system to complement classes for large-scale development. The class system gained features, e.g. Java-style interfaces, and also lost several features, e.g. multiple inheritance, throughout these versions. The language evolved throughout a number of successive versions, and gaining milestone popularity in version 53, leading to extensive work, and the following version 100, which would be equivalent to a 1.0 release in current popular version systems. The next major revision was named version 200, which introduced a new default module system that cooperates with macros. In particular, the module system ensures that runtime and compile time computation are separated to support a tower of languages. Unlike units, these modules are not first-class objects. Version 300 introduced Unicode support, foreign library support, and refinements to the class system. Later on, the 300 series improved the performance of the language runtime with an addition of a JIT compiler and a switch to a default generational garbage collection. By the next major release, the project had switched to a more conventional sequence-based version numbering. Version 4.0 introduced the #lang shorthand to specify the language that a module is written in. Further, the revision introduced immutable pairs and lists, support for fine-grained parallelism, and a statically typed dialect. On 7 June 2010, PLT scheme was renamed Racket. The renaming coincided with the release of version 5.0. Subsequently, the graphical user interface GUI backend was rewritten in Racket from C++ in version 5.1 using native UI toolkits on all platforms. Version 5.2 included a background syntax checking tool, a new plotting library, a database library, and a new extended REPL. Version 5.3 included a new submodule feature for optionally loaded modules, new optimization tools, a JSON library, and other features. Version 5.3 introduced major improvements to Dr. Racket. The background syntax checker was turned on by default, and a new documentation preview tool was added. In version 6.0, Racket released its second-generation package management system. As part of this development, Principal Dr. Racket and Racket repository was reorganized and split into a large set of small packages, making it possible to install a minimal Racket and to install only those packages needed. Version 7 of Racket was released with a new macro expander written in Racket as part of the preparations for supporting moving to the SHA scheme runtime system and supporting multiple runtime systems. On 19 November 2019, Racket 7.5 was released. The license of Racket 7.5 was less restrictive. They use now either the Apache 2.0 license or the MIT license. On 2021 February 13, Racket 8.0 was released. Racket 8.0 marks the first release where Racket CS is the default implementation. Racket CS is faster, easier to maintain and develop, and is backward compatible with existing Racket programs, has better parallel garbage collection, and typically gives a 10–30% reduction in the size of generated code. Features: Racket's core language includes macros, modules, lexical closures, tail calls, delimited continuations, parameters, fluid variables, software contracts, green and OS threads, and more. The language also comes with primitives such as event spaces and custodians, which control resource management, and enables the language to act like an operating system for loading and managing other programs. Further extensions to the language are created with the powerful macro system, which together with the module system and custom parsers can control all aspects of a language. Unlike programming languages that lack macro systems, most language constructs in Racket are written on the base language using macros. These include a mixin class system, a component or module system as expressive as ML opaque ascription, and pattern matching. Further, the language features the first contract system for a higher-order programming language. Racket's contract system is inspired by the design by contract work for Eiffel and extends it to work for higher-order values such as first-class functions, objects, referenced cells, and so on. For example, an object that is checked by a contract can be ensured to make contract checks when its methods are eventually invoked. Racket includes both bytecode and JIT compilers. The bytecode compiler that translates to an internal bytecode format that is run by the Racket virtual machine, with the JIT compiler translating bytecode to native code on x86, x86-64, ARM, and PowerPC platforms at runtime. Since 2004, the language has also shipped with plaint, a package manager that is integrated into the module system so that third-party libraries can be transparently imported and used. Also, plaint has a built-in versioning policy to prevent dependency hell. At the end of 2014, much of Racket's code was moved into a new packaging system separate from the main code base. This new packaging system is serviced by a client program named Racket. The new package system provides fewer features than plaint. A blog post by Jay McCarthy on the Racket blog explains the rationale for the change and how to duplicate the older system. Integrated language extensibility and macros. The features that most clearly distinguish Racket from other languages in the Lisp family are its integrated language extensibility features that support building new domain-specific and general-purpose languages. Racket's extensibility features are built into the module system to allow context-sensitive and module-level control over syntax. For example, the #app syntactic form can be overridden to change the semantics of function application. Similarly, the #module begin form allows arbitrary static analysis of the entire module. Since any module can be used as a language, the module-level extensibility features are combined with a scheme like hygienic macro system, which provides more features than Lisp's expression manipulation system, Scheme 84's hygienic extend syntax macros, or R5RS syntax rules. Indeed, it is fair to say that the macro system is a carefully tuned application programming interface API for compiler extensions. Using this compiler API, programmers can add features and entire domain-specific languages in a manner that makes them completely indistinguishable from built-in language constructs. The macro system in Racket has been used to construct entire language dialects. This includes typed Racket, which is a gradually typed dialect of Racket that eases the migration from untyped to typed code, lazy Racket, a dialect with lazy evaluation, and Hackett, which combines Haskell and Racket. The pedagogical programming language Pirate was originally implemented in Racket. Other dialects include FR-Time functional reactive programming, Scribble documentation language. Racket's core distribution provides libraries to aid the development of programming languages. Such languages are not restricted to expression-based syntax. In addition to conventional readable-based syntax extensions, Racket's hashlang makes it possible for a language programmer to define any arbitrary parser, for example, using the parser tools library. See Racket logic programming for an example of such a language. Programming environment. The language platform provides a self-hosted IDE named Dr. Racket, a continuation-based web server, a graphical user interface, and other tools. As a viable scripting tool with libraries like common scripting languages, it can be used for scripting the Unix shell. It can parse command line arguments and execute external tools. Dr. Racket IDE. Dr. Racket, formerly Dr. Scheme, is widely used among introductory computer science courses that teach Scheme or Racket and is lauded for its simplicity and appeal to beginner programmers. The IDE was originally built for use with the Teach Scheme project, now Program by Design, an outreach effort by Northeastern University and a number of affiliated universities for attracting high school students to computer science courses at the college level. The editor provides highlighting for syntax and runtime errors, parenthesis matching, a debugger, and an algebraic stepper. Its student-friendly features include support for multiple language levels, beginning student, intermediate student, and so on. It also has integrated library support and sophisticated analysis tools for advanced programmers. Further, module-oriented programming is supported with the module browser, a contour view, integrated testing and coverage measurements, and refactoring support. It provides integrated, context-sensitive access to an extensive hyperlinked help system named Help Desk. Dr. Racket is available for Windows, Mac OS, Unix, and Linux with the X Windows system, and programs behave similarly on all these platforms. Code examples. Here is a trivial Hello World program. Running this program produces the output. Hello World. Here is a slightly less trivial program. This program, taken from the Racket website, draws a Sierpinski triangle, nested to depth 8. Using the #lang directive, a source file can be written in different dialects of Racket. Here is an example of the factorial program in typed Racket, a statically typed dialect of Racket. Applications and practical use. Apart from having a basis in programming language theory, Racket was designed as a general-purpose language for production systems. Thus, the Racket distribution features an extensive library that covers systems and network programming, web development, a uniform interface to the underlying operating system, a dynamic foreign function interface, several flavors of regular expressions, lexer/parser generators, logic programming, and a complete GUI framework. Racket has several features useful for a commercial language, among them an ability to compile standalone executables under Windows, Mac OS, and Unix, a profiler and debugger included in the Integrated Development Environment IDE, and a unit testing framework. Racket has been used for commercial projects and web applications. Notable example is the Hacker News website, which runs on Arc, which is developed in Racket. Naughty Dog has used it as a scripting language in several of their video games. Racket is used to teach students algebra through game design in the Bootstrap program.